In the complex world of physics, computing has become an essential tool influencing the way we solve mathematical problems and uncover new insights.
In our research, I've come from the area of material science, for example. Then there are quite a number of colleagues who are doing research in that area. In my area, for example, we are trying to model new materials for solar cells. Now, when you look at it, for example, when you are going to model materials for solar cells, if you go to the lab, you are going to spend a lot of time trying to pick which is the right material. So what we do is we went to computational techniques, because then you can actually build a model, and then with supercomputers within a short time, it will be able to actually give you exactly what you need to, the selection of material that you can put in place.
Computer technologies have transformed physics, incorporating advanced methods to deepen our understanding of the natural world.
The modern developments in computer has given us more tools than we ever had before for carrying out both the experiments and also the analysis of the data that is collected from the experiments.
Physicists leverage algorithms and the large processing power of computers to test their experiments, make scientific predictions, and drive innovation.
So computing is a tool that we have to know how to use, but we're not theorists of computing. So in the end, whatever works for us is fine. Of course, sometimes you have some requirements which are hardware requirements or time requirements, and in that case then you need to go much more in depth, in detail.
The School of Computational Techniques, organized by the University of Nairobi Department of Physics, comes at a critical time when the demand for advanced computational skills in the field of physics is rapidly increasing.
So that is why we look at it. Computational is now what I can call the input, right? Applicable in society, applicable outside. So we thought about, we begin, this is the first school actually we are hosting in the country. So we thought about is, let us first of all, I think, create awareness, and also I think promote, right, computational technique as a way of an enhanced skill in students, but also problem solving.
The pilot program attracted over 30 undergraduate and postgraduate physics students from across Kenya over a week-long period of immersive learning.
Yeah, we're learning a lot, especially on the physics side. Like currently I'm in second year, so we've not gone into depth in physics.
The students not only interacted with leading professors and researchers, but also gained essential skills in programming, computer operating systems, and statistical analysis.
So to know how to use Linux, as a normal student, you're used to Windows, and sometimes you find that the kind of research I'm doing, I need to do something, to develop models for machine learning and deep learning.
Students who have computational skills have a competitive advantage when they go out compared to a person who does not have additional skills apart from the content that we give them. So that's why we thought of giving them these skills that are actually needed now in the modern world.
One of the problems of physics, and especially material physics in Kenya, is to have access to the equipment that allow the experiments. Those equipment are very expensive, and most of the time, well, you don't have them here. So what you can do is using computers to simulate the experiment, allow you to get pretty close to the result, or even to the same result as the actual experiment. And well, you will be saving a lot of money and a lot of time, but you need to have the skills. You need the skills to use computer science in physics in order to do that.
Computational skills are crucial for students as they help to predict outcomes, build simulations, and analyze data.
Right now, we have accelerated. We are dealing with big data, data-intensive research, data-intensive learning, and the students need to know. So this School of Computational Techniques is so important, especially for our drive towards open science, which is data-intensive science and compute-intensive science. It is said data is now the new microscope for science.
The success of ScoTech is a testament to the partnership between the University of Nairobi, the French Embassy and the Kenya Education Network, which highlights the role of high-level collaborations in advancing STEM education.
Well, for us, we want to increase the partnership between Kenya and France, and especially the University of Nairobi, in science, technology, engineering and mathematics. So a school that brings together students in physics and computer scientists is of much interest for us.
We are very committed, especially to developing young graduate students in STEM areas. We have identified the STEM areas of engineering, physics, computing science, medicine and agriculture, and of course educational technology. And we support young, especially faculty who have PhDs.
Having launched this course, we hope the people, first of all the networks created today, will form further networks for collaboration, will form platforms for generation of ideas, and we hope that this course will be given every year.
UNC TV, empowering you.